Welcome to Advent of Code Day 8. My wife just sent me a funny image. She's having the stream on the big screen at home, so that's nice. Thank you for the support. So yeah, Advent of Code Day 8. Let me drop a link in the chat. Here is the link for today. And let me resize this so that it fits the stream size. Something like this. At least then I'll know when I'll go off screen when reading. Don't need that. Okay. I think that's it. So, Haunted Wasteland is called Day 8. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she just finished warning you about ghosts a few minutes ago. One of the camel pouches is labeled Maps, sure enough. It's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left to right instructions, and the rest of the document seems to describe some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach ZZZ. This format defines each node of the network individually, for example. Okay, so this, I think like part 1 is a simple follow the rules, and then part 2 it's like, oh no, these are direct links and you have to do an inverse map and like an A star or something. So yeah. So these are the maps. Starting with AA, you need to look up the next element based on the next left-right instruction on your input. In this example, start with AA and go right by choosing the right element of AA, called CCC. Then L means choose the left element of CC, which is ZZZ. By following the left-right instructions, you read CZ in 2 steps. Okay. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. Okay. So RL just means okay. So that's an instruction that repeats, wraps to the end, and so on. For example, here is a situation that takes 6 steps to reach ZZZ. Okay, this is fine. Starting at AA, follow the left, right, etc., etc. Okay, seems straightforward enough. So let's take the test cases as well, but first let's set up the day first. Let me move this into view as well. And I'll zoom in a bit so that everybody can read it properly. And let's make day 8. So this becomes day 8. The base class specifies day 8. And as always, if you want to know how this works, there's a video in my channel that shows you what this does and how it pulls in the inputs automatically. I should put up a card like in the chat. Oh yeah, also before I start, before I forget, I'm wearing my new Max Verstappen Christmas sweater, which yeah, thought I'd show it off. I really like it. So yeah, let's see. Let's take the test inputs for now. And I think we'll start, it doesn't matter, we'll do them both. Let's do it like this. Bool test modus is true. True. If test modus input equals this. Right, that is fine. We should parse this. So basically it's a double new line separated, followed by, and then each line is like that. Okay. So what I could do is just input.toLines, and this will skip any empty entries in here, because that's my my thing like that. So var lines is this. So char instructions, and I just define this as a char array because we will be wrapping around constantly, is lines 0 to char array. And then we need to have a dictionary with string, comma, a string left, string right, like this. And this will be our map. This will be lines that skip 1, select. Let's build this out. Skip 1, and then select. So here we will do x.split by like this. I can actually do it like this. I can do actually trim end like this, so that it will remove the trailing accolade. And this one will split on this section, so it will trim the first one, and this one will leave us just like so this will turn this into like this, right? Let's see, we do it by that, and then we do as. I need to array as, yes. So let me also put that here. Something like this. Let's see. Let me just indent this so that it's at least a bit readable. Right, and now we do the first thing will be x dot, this will be just this because it's the string that we want to preserve, and then we do x dot split by, and I do it like this to swallow all the spacing, etc. And we do this as well. To array as, and then I can do y dot like this. And I think this should be it. Then I can do this should actually be to dictionary. Let's see the as, what does it return here? Can I do it to dictionary? No, because it will do that. I can do that on this level to dictionary x dot item 1, and then I do x dot item 2. So this parses it all the way down to this. It might look a bit messy, but it works. This basically just turns it into a string value tuple like here, and having the definition here defines the names there. So this is our input parsed. So let's write that actually. For each var key in map.keys console.writeLine so we do key, our entry is map key, and then we specify the explicit type, we declare it outside, and now we can do entry.left, entry.right. Okay, so if we run this now, we should at least have the input mapped. Right, so we have all the steps mapped. And now we can actually walk the data. So we should probably const start is now const string start is AAA and is ZZZ. String current position is start, while current position doesn't equal to end. Const int sanity upper level is, let's do 100,000 here. Int steps is 0 and steps smaller than sanity upper level. Okay, like this. So now we have our infinite loop, which breaks out if we make a mistake. Left means L, right is R, so we have those defined as well. These are chars, of course, const char, like this. So now we have all our data defined. Let's move this to the top of the class. And actually we can do this here as well. So yeah, these are our working variables. Let's see, current position start. So now, instruction index. But the thing is, efficiency wise, what I could do is just always mod the steps to get the index, but that is less, it's not that bad. But the thing is, if we don't, we have to increment 2 numbers. So for just a little bit of cleaner code now, I'll just use that for now. So let's do that. So we do current position equals map current position. So we can do entry this actually. And now what we can do is I need to have the instructions that's like this. So instructions steps percentage instruction length. So let's do this. Instruction length is instructions.length. This is a constant. Okay, it's okay. And it's not written correctly. Okay, like this. So this one, and this needs to be mod. Left. Then we do entry.left. Otherwise we do entry.right. Okay, so this shifts it over. The only thing is that the steps will be one behind. Let me just do it anyway. Instruction index is 0. And let's just do this. If ++ instruction index larger equal to instruction length, instruction index becomes 0. So this is a lot lighter than the other way around. So let's just do this. And now we can do console White line, part 1, steps, and this will be steps. Okay, so let's run this. 2 steps. Okay, that is fine. Let's take the other test input, make sure that that also works. 6 steps, that also works. False. Let's run this on the real input, and I should probably not print out everything, but it's 2197 steps. So that is fine. And now we get ready for the twist of part 2. Woohoo! Part 1 done. I think this is the fastest part 1 so far. Because with reading and everything, it's just a few minutes. Okay. Let's see. Part 2. I think this was the easiest part 1 so far. So I'm worried what part 2 will hold. The sandstorm is upon you and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the law of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number of ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all the nodes, all of the paths at the same time until they all simultaneously end up with Z. Okay. Let's see. So this is what this is an even more difficult twist. So let's do this. Input is like this and continue reading. Here, there are 2 starting nodes, 11A and 22A, because they both end with A. As you follow each left-right instruction, use that instruction to simultaneously navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on end with Z. If only some of the nodes you're on end with Z, they act like any other node and you continue as normal. In this example, you would proceed as follows. Okay, so this is like a repeating pattern, so you will have to, yes, okay. So I think the trick here is to find the greatest common divisor, which means that you find out the length of each one individually and then multiply them by each other, I think. Let's see. Step 1, blah 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 blah. Here one goes to Z after 2, 3, 4, 6. So in this example you end up entirely on nodes in the end Z after 6 steps. So yes, okay. So yeah, you have like this is on 2, this is on step 3. So 2 times 3 is 6, and as you can see here they come. Okay, so that's the trick here. I think I've seen something like this before, so I'm glad that I caught it right away. So this should be fairly straightforward. We just have to find all the A's, do them individually as before, and then multiply them together. But there might be, I think I have like an extension, like greatest common factor, yeah, like this. So I need to remember largest, lowest common factor. I don't even remember what it stands for. I looked this up last time, so I'll play around with those numbers and see if it works. So yeah. So in this example, you end up entirely on nodes that end in Z after 6 steps. Simultaneously start on each node that ends with A. How many steps does it take before you only on node that ends with Z? Yes. Okay. So first let me see if I can find all references where I've used this before. I haven't. Great. Ah, okay, I did it before in other. I had them local there. Okay. Nope. Why do I carry this around every time? You'd expect me to at least have used this somewhere in the code. No, so I have it in my code, but I can't find the place where I actually use it. So yeah, we'll figure that out later. Okay, so for part 2, we do map dot, oh no, map where x dot key ends with a. Let's just do start 0 like this. To select key. Sure. So var starts equals this, and like this. So now we have our start and end positions. Let me just let's remove this. So we can say console.line starts, and it's endings probably, but it's fine. I can butcher the language a bit. Starts that count. Okay, so let's run this. We have only 6. Oh, because we're still at the. I set back the test input, right? No. Okay. I'm worried that it's only 2. Oh, what happens here? Ha! If I set this input, it fails the first basic step. That's interesting. So they have dead parts here or something? Cool. Okay, so let's just take this piece and make sure that we do that after we've processed part 1. Okay. And now we set the input here. It's fine. Ah, no, that also means that I have to do the mapping. Okay, you know what? Let's use the actual pieces of code that were meant to go there. Sorry. Boom, boom, boom. This is fine for everything. So this becomes part 1. Sure. I need to pull out this piece here as well. Okay, so now we extracted everything. Okay, cool. So we have the part 2. So now what we can do is for each string s in starts Let's just keep a dictionary of string int lengths. New, I don't need to have type information there. And I should probably actually turn this into a function. We don't need to write this out at all. So what I could do is int get path length, string start, string end, and then we have the map. And we have a char array of instructions like this. Okay. So basically you get this area here. And okay. And then we do return steps like this. Is this correct? This becomes instructions, instruction index, and this will, let's see, int instruction length equals the length. Okay, so now we have a function that just does get length. So now what we can do here is int part1 equals get path, and this will be start and map comma instruction like this, and now we can take away all of that. And if we run this, it should still work now, which is fine. And now we can use the same for part 2. So now inside this loop, we use the refactored logic. We do length is get part length. This becomes s. Yeah. That's actually so what we can do here is list string start, string end, pairs is, and then we do start with indexes, and then we do x, let's see, select x, and this one becomes x dot value, comma, ends x of index, like this, to list. And now we have it mapped. So basically what we do is, because they're all in the same sequence, no, that's not correct. Because the prefix needs to be the same. I did that wrong. So let's not do this. This actually needs to become dot substring 0,2. Actually now length -1, just in case there are variable lengths, or we'll run a bigger input. Like this, and this will actually become a actually, we don't even need to map the ends, because we will know the ends based on the starts. So that is fine. So we just take the identifier part and then we swap in the end. And this will be starts select x. We use a string format to build the start and end here. I think this is the even better way to do it. So we'll have xa, and let's also use the same part here. We use the starting, and for this one it will become the ending. Like this. Oh no, you don't need that because it's already there. Like this, and then dot to list. Okay, so what we do is we find everything that ends with a start marker. We take everything except that start marker at the end and then build out the start ending pairs with that. So now we do, this becomes for each var pair and pairs. And this is pair.start, pair.end. And then we do lengths.add. This becomes pair, comma, length. And let's just put it in like this. Boom. So we do pairs. And now I wonder if we need to add the first starting one as well. So we do pairs of count. Lengths. And then we do string.join. Let's just dump them out here. Lengths.values. Like this is, and then we do long factor is 1 for each. Actually, I can do this while we calculate it here. And let's go back to actually having the length here. So long length is this. We just cast it here. Actually, it should be an int, right? So we do factor times equals length. So this one should give us the value 236. Yeah, that is fine. That was the only test input there. So let's run the real input. False. So that's a big number. Oh, wait, what? How is that possible that they all conclude at the same way? This is something weird. Ah! They all have their sanity check enter actually. Wait, that is weird. Why do they? Sanity upper level. Why doesn't that complete in 100,000 steps? Okay. That scares me a bit. Let's give it 1,000,000. Nope. How is it possible that it doesn't work with 1,000,000? Nope. Okay. So let's read this, and I think you choose all of the left bars. Yes. I don't get this. Did I do something wrong for the pairs? Let's see. FQZ, FQA, okay. So why do they never end? let's say if it goes for 1,000,000. Will it find something? Is there a way to even break out or not? This is just for one, right? Nope. It won't be able to get there in all that time. So now we have to look at the path that it takes. Which is annoying. So let's see. Because the first one was like, let me see, FQA, right? So let's see the unique things that we've seen. Hash set string nodes visited is new. Boom. Add start. No, start. Entry. No. We just do current position here. Right. Oh, this one. I'll do the same here. Let's break here. And let's do that. Sanity check goes back to 100k. And this is why you have stuff like sanity checks, just to not wait forever. And I want to do this as soon as I do part 2. So let's stop here. Let's do this. Okay, now I set my breakpoint here. Nodes visited is 123. So the trick will be to figure out how this changes and how many times you need to run before something switches, which is annoying. Because there will be a pattern emerging after a few runs, because you have like, there are 300 something statements in there. So yeah. The issue with this is that this is one of those things where you have to actually know the solution to be able to do it, because there's a shortcut that you can take, and I'm not sure if I know it. Because as I said, I know some of the things. I was able to do the shortcut for this, but that's only because I can actually get to the end. But there's also a trick where you can find a shorter way to calculate how you get to that end, which is, yeah, annoying. Because basically you have to factor, I think what you need to do is do a full run of all the instructions, map out the path, and then map it out again. So let's see, we can do string path taken is new, like this, and we do path taken add current node current position, like this. We'll do the same here. We don't need the nodes visited anymore, actually. And here, when we reset, we will do nodes visited. Oh, no, nodes. Path taken. Sorry, path taken. Here. But we want to save that here. So we do a list of string full paths per run is new. So we do add string join like this. Paths taken. No. Path taken. Like this. So let's do this. Let's actually do a few. Quick watch. Let's take. That's an issue because I have so many things in here. Let me just take a regular notepad, which is annoying AF. Let's disable word wrap. Even with word wrap disabled, it will still word wrap. That is funny. So word wrap is disabled, but it's like, hey man, this string is too long, I'm not gonna do that. Okay. Ideally, we would be able to find like a pattern emerging, but I'm not holding my breath for that. So yeah, let's go back here. We should never go back to AA. Okay, what we can see here is that we repeat HVT XRF. See, so there is a sub pattern there, and now the question becomes how big is that pattern? So this isn't it. Let's see if I just do this. Okay, looks like to the left there is some repeat, not to the right. Ah, here. This is funny. So you have XRF, RQT, SQT, and then H. So this one takes a different path and then arrives at this one as well. And then it does a different path and it arrives at this one as well. Do you see that? And then it visits this one as well. So now I'm wondering if there's like a pathfinding trick. Like if we would work backwards from, let's see the input, which was the one that we were testing here. Oh wait, this is AAA, okay. Ah, wait, haha, okay. Maybe No, because it did that for more. Never mind. I was like, maybe I'm not supposed to do the AAA one anymore, but that's nonsense. But wait, why didn't it actually do the AA one? Ah, this was the... Let me see. I'm not sure if I know the way, because what I was thinking is maybe we could do like a reverse pathfinding here. So like 2Z. So if there's one, the end positions always have the same left and right. You can't go out of it, right? Oh no, this is one is here. 2Z. This one will go to 2B. This one will loop around, right? Okay, and this one will loop around. Oh, did I have my sanity check wrong? I might have. No. Nope, that's not it. Let me think. This is a tricky one. I'll give it a little bit more, but if not, I'll admit defeat and look at how this is done. Z, actually A is here, so FQA, so FQZ. Why is there no FQZ? Did I... FQZ. There is no FQZ, what the... Are they trolling me? Oh, okay. That is strict. That is so sneaky. Repeat this process until all of the nodes you're currently on end with Z. It's not. It doesn't have to match explicitly. Jesus. If that's the issue, I'm gonna be so mad. Okay. Okay, let's see. Bool ends with is and 0 equals star. Okay. If ends with and is and dot substring 1. Do it like this. That is so annoying. But that's the value of reading right, you know? So this now becomes this now just becomes like this. Sunka Suffer. Hey Nick, good to see you streaming. Yeah, good to have you in the chat, mate. Welcome. Have you done today's challenge? So this becomes star Z because this will be a wildcard match. So let me run this again. Okay, that's interesting. Let me check this. This becomes not answerable. Wow, we actually have a result. Let's see if this works. Answer is too high. Okay, so now I need to probably factor these and see if that works. Not yet, just getting ready to go to work. Okay. It's a tricky one, and there is a small thing in the code, in the text, that really made me trip up. So I don't know. I don't want to spoil it for you if you want to do it yourself, but that really got me. Let's see. Greatest common divisor. Alright. Let me just. $307. No, I need to have it where it all aligns. That is funny. Is this true? 18727 divided by 307, 61. 24253 divided by 307. Ha! Funny. That's not correct. Let's see. 24253 divided by 307, 79. 18113 divided by 307, 59. That is funny because 307 is actually the amount of instructions. So it's funny that every solution is actually divisible by the amount of instructions here. So in this case, since they are all common divisions, I think the smallest number of these is actually the answer. Which is funny. Boom, boom, boom. Oh no, that's not it, because they have to align. Bum, 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 bum. It's not GCD in this case, because at 307 they won't. These are the first numbers where they'll meet. So it's find first number where all how did I even Google this? I think I need to multiply each one by them and see what the lowest number is actually. So I can do that, I think. Let me think. So for here, I think it's lengths dot values get permutations to false for combinations is and then I can do list. I can do combinations dot select x dot a because this will be a enumerable of int. Okay, Jesus. This. These are longs, right? I think. No, these are ints. Okay, I need to cast these to longs because otherwise I won't have it. Answer. Oh no, I need to have the highest number, I think. No, because it needs to be... Jesus. Let me think. Because what I need to do is find one number that works for all of these. Let me just see what this spits out, because I don't think that's it. So let me see, if I take this divided by 18727, no. So that's not, that doesn't work for all of them. Let me think. Oh wait, what I think I can do, since the greatest common factor is 307, if I divide all of them by 307, then times those numbers together, would that be it? Let me see. So we do this divided by, actually, like this. We don't need to do the permutations. Let's see, we have length.values, select x divided by instruction length. And then I need to time all of them together. Long alt and alt factor is 1 alt. And let's do alt factor times equals len divided by instruction length. Let's see what that spits out. I need to have the alt factor, because that will be a much more manageable number. And let's see, calc, this divided by 1872, it's a fraction. How is that possible? Okay. Was I wrong about the instruction length here? That was 307, right? Yes, that's also the factor between all of them. Because all of those numbers are divisible by 307. So I'm just missing a piece of knowledge here, as you can tell. And I think that I want to make sure. Okay, so let's boom. This divide by 18727, that's divisible. Okay, divided by 24253, that is divisible. Divide by 18113, that is also divisible. Divide by 22411, boom, I think I got it. Divide by 21797, boom, and this divided by 16271, also correct. Okay, so I think this one should be the solution. And if it's true, I will be really proud of myself. Woo! Yes! I don't think I've ever been so proud that I figured it out myself. Jesus Christ. Okay. Ha! Okay, that was cool. Nice. Ah, man, that really put me to the test, because I don't fully grasp the concept. So it, yeah. Like I said, thanks. So what you can see from the test example here was that it finds an endpoint for both of the numbers at position 2 and position 3 for the first time. So if you multiply those together, the first time where they meet up is position 6, but there's actually some trickery involved there because so to find, I did the greatest common factor between all the results. And funny enough, the greatest common factor is actually the length of instructions that you get. I don't know if this is true for everybody, but that was the number that came out, and I should probably not hard code it like this, but actually calculate the greatest common factor. So yeah, let's see. I can do that here probably. GCF. I have an extension for that. GCF. Don't I? Yes, GCF. So I probably need to do that for each of them together. I will need to look into how I do that, because I have not done that before. But basically I calculated the greatest common factor here, which was, for me, the length of the instructions. So I do that here. So what I do is I take the length, I calculate the unique path length for each of the things that you have to calculate, because they say you have to do it in parallel and keep looping till they all end up at a Z spot, which you don't need to do. And once you have that length, you track it, of course, but it's also like this factor is, if you multiply these together, you will have a number. Let's see, Subcode Software says, I think I need to update your extension method class. Yeah, I'll need to take some time to put everything that I do nicely on GitHub so that people can take it. I've added a bunch of stuff there. I need the new methods, yes. So basically, if you have this repeating pattern where numbers arrive at their destinations out of sync, what you can do is, if you multiply all of them together, you will have a number where for sure all of them will end up at the same spot. But in this case, that doesn't have to be the smallest number that they arrive there. It could have happened a few times already. So what I did here was to make sure that I, since they have a common factor, the greatest common divisor, so a number where all of these can be divided by, I divide all those numbers by that to get their smallest C number, and then I multiply them together, and in the end I do it times the instruction length for once to find the first occurrence where they repeat. So yeah, this was really, really cool. This was, I'm so proud of myself for arriving here, because I was like, once I ran into some bottlenecks, I was like, okay, I'm not going to be able to solve this, but yeah, good job, Nick. I'm really happy with this because it was so tricky. Damn. Yeah, this was cool. This was cool. This gets me fired up and happy. So yeah, and I can take all of this out because this was all debug code. I don't need it. Boom. Oh yeah, I leave this in here. This is the way that the parsing works. So yeah, I'm really happy. If you just, because I see the viewer numbers fluctuate a bit, if you just step by to watch, and we actually don't need to track it. Basically what my solution was, I have some markers here for, like, the first part. They say start at this one, end here. This one indicates a left move, this one indicates a right move. Since there's only two moves, you only need to define one, because if you find something else, it will be the other move, but you could add a sanity check, but I have them defined here. I have a small switch statement to enable me to bypass the input and set a test input that you can see here. I did them one by one, so I just added the later one so that I can disable it if I want to. So then, yeah, the input is fairly simple. it starts with a line with instructions, then a blank space, and then you have all your mappings. I have an extension method that just strips out all the new lines and just gives you an array of lines with data. So then I pull out the instruction, I take the first line, I put it as a char array because it has to wrap around. So you start at index 0, then index 1, and if the length is only 2, after that you get index 2, but it's longer than the length, so you wrap back to 0. And it's easier to just have the char array here. I cache the instruction lengths to not have to call it every time. This is my ugly mapping function, and the real magic here is always the as extension that I have. It looks like black magic, but it really isn't. Basically, it creates value tuples, which are these. And as you can see here, before I return, they are named item 1, item 2, etc., which is default for tuples. But because I define the type here with nice names, my map will actually form itself to have this nice mapping of having a starting point with their branches to the left and the right. So basically I skip the first line, which is the left-right instruction set, and then I trim off the excess brazier, the round angle thing, and then I split by this string, which removes this part, so then you end up with just the from, and then a comma separated to. So this is just to not have to trim out the roundings there. Since it's an IEnumerable, I put it as an array so I can use my as operator, and probably I should have an overload that takes an IEnumerable and just caches the data there, and then it just it splits the second part and into just 2 strings. So this looks like, why do you do this? But this is just to make sure that it maps as a value tuple. So then we have everything nicely mapped, and we convert it to a dictionary so that you can actually look up the next step. I had the code inline here, but I extracted it into a function because we can use the same logic in the part 2. And this is just the logic to get the part lengths. It has a start and an end. For part 2, this was really tricky because I had, as I showed you above, like you have these while loops, and if everything is correct, they end and it's all nice. But oftentimes you'll make a mistake or there's something wrong with the data and you'll end up with infinite loops. So what I try to do, if I have a loop without a hard out, I'll add a hard out. So in this case, I say 100,000 iterations is the max that I'm willing to spend on this logic. If I get to 100,000, I'm pretty sure there's something wrong. So I added a sanity check here, which triggered my second part. And that was the reason why I have this one in here. So for part 2, they have a tricky example where they say anything that ends with A is a start and ends with Z is an end. And in their example, you have 11A and it ends at 11Z. And you have 22A and it ends at 22Z. So I made the assumption that they would match the starting and end points. But it says just if all of the nodes you're currently on end with Z. So they don't specify that the part before has to match, because it will never match. So if you look into your input, Z equals, and I'll take this one, FBZ, there is no FBA, and vice versa. So if I do for A equals, and I take the top one, this is one that I found, and I do Z, there is no matching endpoint. So if you try to do that, which I did, it will, it won't work. So that was a really tricky one that I had to account for. So after that, I added this. So if you want to just look for the ending, you can start with a star, you strip off the star, and then you have an inline if that checks it. Like performance-wise, having this if in your while branch isn't the most optimal, and I hope that the compiler just branches off that into 2 paths so it only executes once, because this will never change. But yeah, if you really want to squeeze out all the performance, you would have 2 functions and just one for the wildcard, so that you don't have to actually switch on that logic. So yeah, this one will just move on to the next entry, etc., and keep track. So for part 2, yeah, I went over that at the end just now. So it's the same parsing stuff, and I should probably have just moved this into the constructor here and have it available to the part 1 and part 2s. But in the end, you never know how it will mutate, so I try to always do it like this. But yeah, I could have this be shared code, and I don't think entry in this case is even used. So yeah, I'm really happy with today. I'm really happy with myself that I figured it out. So yeah, the 307 here is instruction length, and let me just add a note here. Note after finding the GCF aligned 100% with my instruction length. I use that. This might not be the case for every input, because this is truly dependent on how the paths are set up. So beware. So yeah, I'm really happy with this. Really happy. I'm going to put this on Reddit proudly, and look forward to tomorrow's Advent of Code. So thank you everybody for stepping by, especially Sunco Software. Always nice to have somebody in the chat, and hope to see you again tomorrow. Bye bye.